डियर स्टूडेंट, सब्सक्राइब बटन और बेल बटन को दबाएं ताकि मेरे वीडियोस आपको सबसे पहले मिल सकें। Bismillahirrahmanirrahim. My dear students, let's have another concept in the topic of trigonometry. And here we have trigonometric functions. There are sine and cosine trigonometric ratios here, and we are going to learn the relation between acute and obtuse angles when we have sine and cosine trigonometric ratios. Here are two results. I have written here sine of A is always equal to sine of 180 minus A, and cosine of A is always equal to minus cosine of 180 minus A. They are very essential in some problems, so let's learn how they work in the problems. Here is one example I have considered, my dear student. Express the following as a trigonometric ratio of acute angle and then find the value of that given function. Here we have two parts, part A and B. Let's find the solutions. This is part A, and we have given sine of 110. The question basically is, first question is we are actually supposed to find the value of sine of 110. But the question is in the sense of the first convert this angle, which is obtuse angle, in acute angle and then find its value. Let's proceed according to this rule. Whenever we have any angle sine of A, we can write in the form of sine of 180 minus A. So this sine of 110 can be written as sine of 180 minus 110. And now if we subtract this angle from this, we will get sine of 70 degree. And now it's acute angle. The question was, first convert this obtuse angle into acute angle and then find its value. And sine of 70 is equal to 0.94, my dear students. Just get from this calculator, you will get 0.94. And here you can see we got the value of 70, that is 0.94. So remember, my dear, sine at 110 and sine at 70 degree have the same value. Now here is the relation, this is the relation, this is the formula that help us to convert obtuse angle into first acute angle and then find its value. Now look at the part number B. In a same manner, but with the help of this result, we will write cosine of this obtuse angle and then we will write it, find its answer, its value of acute angle. So this will be equal to minus cosine of, this is 180 minus 175. Now subtracting this from this, we will get minus cosine of 5 degree. This is now acute angle, the given was obtuse angle. Now let's get the value of this. This is minus sine, and this when we operate cosine 5 on calculator, the answer would be 0.99. Now here we are learning how obtuse angles can be converted into acute angles. And here again we have given obtuse angle, and with the help of this result we have converted in acute angle, and then we get the value from calculator of these acute angles. Alright, my dear, let's see next in a coming up example what is the use of this concept instead of this direct calculation, what is the use in different problems, and we will learn that. Alright, my dear students, let's have example number 2 related to this concept of obtuse angle and acute angles of sine and cosine trigonometric ratios. Here is example number 2. We have given this right angle triangle ABC, in which right angle is at point B, and these are three measurements given, that AB is 15, BC is 8 and AC is 17 centimeter. There is a point D on the straight line BAD. Now the question is, we are supposed to find the value of part number A, tangent of ACB. If we look at this right angle triangle, the angle ACB is AC C and B. We are supposed to find the tangent of this angle. This. And we have already learned how to write the ratio of trigonometric functions when the angle is given. Let's define sides of this right angle triangle. Alright, so part number A, we have tangent of ACB, my dear students. And to find its value, we are supposed to focus on right angle triangle and assess its sides according to this angle C. Because the middle of this angle is actually the angle where angle is. So, according to this angle C, this is opposite, this is adjacent, and this is hypotenuse. So, opposite over adjacent is equal to the tangent trigonometric ratio. Its value will be directly opposite is 15. We will write here 15, and adjacent, that is 8. So tangent of ACB got this value in the form of fraction. In part number B, question is, we are supposed to find the value of sine of DAC angle. This angle, DAC, this angle. We are supposed to find the sine of this angle. And how will we work? Look at here. Let's write it again. Sine of DAC angle is equal to, let's get help from this relation. We can write in the form of sine of 180 minus DAC angle. So when we subtract this angle from 180, if we look at this picture, this total is line, a straight line. At the point A, we have total angle 180. If we are subtracting this angle from 180, so we will get this angle inside the triangle, that is BAC. So the conclusion of this one, subtracting this angle from 180, will give us the angle of sine of BAC, my dear. This was obtuse angle, and this formula help us to convert this obtuse angle DAC in the form of acute angle. We write with the help of this conclusion, the sine of DAC can be written as sine of 180 minus DAC. And when this we subtract from 180, if you look at here, if we subtract this angle from this total angle 180, we will get this acute angle, that is BAC. Now, we are in right angle triangle. According to this angle, this is opposite, this is adjacent, and this is hypotenuse. So to write the value of sine of BAC, we pick the opposite 8 and we pick the hypotenuse 17. So our value will be 8 over 17. This is final value of this part, that is the sine of DAC, although it was outside, exterior and looking angle outside, but with the help of this we can convert the acute angle, and then from this given right angle triangle we can write their ratio. We have part number C. We are supposed to find the value of cosine of DAC angle. So with the help of again this is the same angle DAC. This is obtuse angle, my dear student. First of all, we will convert in the form of acute angle with the help of this result, and this can be written as, let's write it again, cosine of DAC can be written as minus cosine of, this is 180 minus DAC angle, because in this situation we are supposed to insert minus sign here. So let's simplify this one. We will get minus cosine of, this will be BAC. How it's become this one? Because when this angle is subtracted from 180, it gives us this acute angle again, as it did in the part number B. So we are here with this angle, cosine of this angle we are here, and now we will see the we will see what side will help us in for the trigonometric ratio cosine. Here is adjacent with according to this angle. This is adjacent and this is hypotenuse. We will write in front of it adjacent value. This is 15 and this value hypotenuse 17 with a negative sign. This negative sign, my dear student. So cosine of acute angle, that is, we are inside this right angle triangle, will be equal to adjacent over hypotenuse. It's the use of acute obtuse angles relation and acute angle relation in sine and cosine trigonometric functions, my dear. I hope you are clear about it. Revise it, you will be more clear, and when come your question, you will be comfortable while using this concept of relation of acute and obtuse angles of sine and cosine trigonometric. Bismillahirrahmanirrahim, my dear students. Here we have example number 3, the use of the concept of acute and obtuse angles. Here we have given a figure. There are two main areas related to use of acute obtuse angle concept in problem solving. One that we have done where a right angle triangle was given, but here it's figure given but with the coordinates and points are given only, and we are supposed to answer by using the same sense of obtuse and acute angles. We have given this triangle ABC with their respective coordinates, and we are supposed to find sine of ABC and cosine of ABC and tangent of ACB, my dear students. If you look at this picture on this graph, things are clear comparatively, and we can assess the things are different, but there are something we are supposed to calculate. For example, there is no direct right angle triangle looking or given. We are supposed to develop the situation from this given graph. Where are the actually values that help us to use this only triangle A, B and C? What I did, I developed or construct, you can say, or get the help from this graph and draw these dotted lines to make the formation of right angle triangle. That will help us to find these three parts related to this question. These coordinate axes where the coordinates are given help us to find sometime if we need to find some length. We can assess this length from this point to this, yes, with the help of this coordinate axis, and we can assess this length, but the question is from A to B we can't assess, we have to calculate this length, so that the three sides of right angle triangle according to one particular angle, as we have already learned, they are might be opposite, adjacent and hypotenuse. Then they will help us to find the value of these three trigonometric ratios, my dear students. Alright, so first of all in solution, I'm looking at this. Let's identify all these sides of this right angle triangle that I have developed with the help of these dotted lines, and then we'll check this third side. Is this side that we are supposed to calculate, or we can directly assess or not? Let's see, let's check it out this side, and let's suppose this point is D point. Then it's mean, let's check the length of these different sides, DB or BD. This is on x-axis 2 units to this side, and my dear students, from this towards left side from origin, these are 2 units. If you look at the distance, how much distance is this from this point? Let's count it. 1, 2, 3 and 4. These are 4 units, my dear students, that we have from D to B. If this is solution here, then let's write the sides of this right angle triangle where BD we got, this is 4 units, equal to 4 units, yes, you can say centimeter, and from D till A you can see from origin this total length is 4, and but this point D is only 1 unit up, if we subtract this 1 from 4, we got the distance of between the point A and D. So AD side is equal to 3, my dear. Now, this side we have length, this is 4. This side we have length, this is 3. Now, because in trigonometric ratio we need all 3 sides obviously. So this longest one opposite to right angle, that is hypotenuse, we also need it. So according to the situation, what the examiner want, what the question writers want, that we need to find the distance between point A and B. And here is the process, my dear students, to find the distance between the point A and B. This is distance AB. We will use the distance formula here, and that is x2 minus x1. Let's write it. x2 minus x1 whole squared plus this is y2 minus y1 whole squared. This formula will help us to get this length A, B. Then we will move to find these parts, part A, B and C, sine, cosine and tangent, trigonometric ratios. So this is point 1 and this is point 2. This is x2 here, this is x1 here. Let's substitute the values. This is 2 minus 2 whole square plus, here is y2 1, here is y1, this is 1 minus 4 whole square. The square root is remain same. Let's simplify a little. 2, and after this there's minus into minus, this become positive. So it will be plus 4 square plus, and we will subtract positive 1 from minus 4. We got minus 3 square here and with the square root, and this will be equal to 16 plus 9, my dear, and this will give us 25 square root and the value is 5. It means we have length AB equal to 5. Now we have all 3 sides in the right angle triangle ADB. All these values will help us to find our all 3 parts. So first one is sine of ABC. Here is part A, my dear students. This is sine of A, B and C. Let's check it out from the figure where this angle is. Angle A, B and C is, our question is, we are supposed to find the value of this, sine of this angle. And to find the value of this angle, we will get help from this trigonometric ratio, this relation formula of acute and obtuse angles, and then we will substitute the value. This is sine of A, B, C. Let's convert here directly. Sine of, this can be written as sine of 180 minus angle A, B and C. I have written in place of sine of ABC with the help of this result that we are using in these problems, and this will be equal to sine of, when we subtract this angle from 180, we will get, look at here, this angle I am subtracting from the total angle 180. When I subtract this from total 180, I got this angle, this side. This angle is A, B and D, and we will have A, B and D, my dear, this angle. It's mean if we have sine of ABD, it's mean we are in a triangle, right angle triangle A, D and B, where according to this angle, this is opposite, this is adjacent, this is hypotenuse. For this, sine of ABC, that is converted in acute angle, sine of ABD, this is equal to opposite over hypotenuse, my dear. Its value is 3/5. And similarly, in the same way, we will find the value of cosine and tangent as well. Let's see, let's find the value for part number, this was part A, this is part B here. And we are supposed to find the value of cosine of ABC. This is ABC, this angle we need to find. Alright, so first of all, we will apply this relation of acute angle and obtuse angle of cosine trigonometric ratio, and then we will carry on from this right angle triangle. This can be written as, this can be written as, that is equal to, according to the result, minus, this is cosine of 180 minus ABC, angle ABC, yes, and this will be equal to minus, again, when we subtract this angle ABC, again, this is the same situation, when we subtract this from the total 180, we will get only this angle, that is DBA, or ABD we will left here. So we will write cosine of ABD angle, no need to write these brackets. So the subtraction of this angle from 180 give this angle ABD, ABD. It's mean we are in this right angle triangle again, and alright my dear students, because we want to find the value of cosine of ABC, and with the help of this acute obtuse angle relation of cosine, we got this angle here, and now we are in this right angle triangle where we have respective sides given according to this angle. This is adjacent that we require for a cosine trigonometric ratio, and this is hypotenuse. We will write its value, this will be equal to minus adjacent, that is equal to 4, and then hypotenuse, that is 5, my dear students. So for part number B, value of cosine of ABC is minus 4 over 5. And now let's move towards the part number C. Let's try to cover here. Part number C is tangent of ACB we are supposed to find. And my dear students, look at here. This angle is A, C and B. Although it's representation only up to here, but if we look at now, look at this figure that I have developed dotted lines, make one small right angle triangle A, D and B, and at the same time if you look closely, there is a larger right angle triangle A, D and C as well. So for tangent we are supposed to consider triangle A, D and C, and in this triangle we will check what sides are given. This side will be adjacent according to this angle that actually we are going to find its tangent. According to this angle, this side is adjacent, this is hypotenuse, and this is vertical, this is opposite. This opposite and adjacent will help us to write the value of tangent of ACB. So my dear, let's check it out. This we know that this is opposite, we will write here. Now let's check the adjacent from here till here. From here up to this line we have 2 units. From here up to this we have 6 units. As a total we have 8 units, this length DC. This will be 8 here, my dear students. So the value of trigonometric ratio tangent we will write directly from the triangle A, D and C. Opposite over adjacent. So my dear students, here I try to explain the use of these two formulas of acute and obtuse angles of sine and cosine trigonometric ratios, and they are used in different type of concepts, different type of situations. One when right angle triangle was given and there one external angle given, and the second here we can have graph given in the form of coordinate geometry sense, where we have only coordinates given, and then again from given graph we learn how to find the value of sine and cosine trigonometric ratios, as well as possibly tangent as well. So keep it up, keep on revising, and get the sense from that is used again and again in all these questions and in different situations. I hope if you carry on revision and practice, you will be able to cope up this kind of questions and could be handled very easily and nicely.